Hi, in this video, we're going to continue our chapter, Motion in Magnetic Fields. So we've considered three main directions: the direction of magnetic field, the direction of current, and the direction of wire's motion. And in order to find any of these, we have to use Fleming's left-hand rule. In this rule, we use three fingers. The thumb goes in the direction of the motion of the wire. The first finger goes in the direction of the magnetic field. And the second finger goes in the direction of the current. The three directions are at right angles to each other. And to predict any of these directions, we have to follow these steps. Rotate your left hand so the first finger is in the direction of the magnetic field. Point your second finger in the direction of the current. And your left thumb is now pointing in the direction of the movement. For example, if the magnetic field points from the left to the right, point the first finger of your left hand to the right. Then the current flows out of the screen. So point your second finger towards you out of the screen. Now your thumb is pointing upwards, and this is the direction of motion. Now try this by yourself. If the magnetic field pointed from top to bottom, and the current flowed into the screen, which way would the wire move? By the left-hand rule. The first finger points from top to bottom, and the second finger points into the screen. So your thumb will be pointing to the left, and that is correct. Now the force exerted on the wire depends on two factors: the strength of the magnetic field and the current flowing through the wire. And the equation of the force is equal to the magnetic field strength multiplied by the current multiplied by the length of the current carrying wire in the field, sine theta, where theta is the angle between the direction of the current in the wire and the direction of the magnetic field. If the current is flowing at right angle to the magnetic field, the equation simplifies to F is equal BIL, since sine 90 is equal to 1.